Hi everyone, thank you for joining us today for this exciting talk. I am Ajeet Singh Raina. I am a Docker captain and ARM innovator. I work for Docker, and today I will be joining Lakshantha, a field application engineer from CD Studio, and we will be presenting together an interesting topic around the rise of no-code AI vision at the edge with Node-RED and Docker. So let us get started. First of all, a little about myself. I work for Docker. I have been part of Docker Captains program for the last 6 years. I am a Docker Bangalore community leader and have been leading a community of around 11,000 members. I'm also a part of ARM Innovator. We have extremely great passion working on IoT devices and AI. I run a Collabinic Slack of around 7,000 members and I have been conducting regular meetups in and around India. Do check out my personal website where I have around 350 plus blogs written on Docker, Kubernetes, and cloud. And in the past, I worked for the companies like Redis, Dell EMC, VMware, and CGI. Lakshantha, can you go ahead and introduce yourself?
Of course, Ajeet. Hello to everyone who has joined with us. I'm Lakshantha from Sage Studio and I work as a field application engineer. I have worked in the industry for about 4 years now, and my main areas of focus are embedded systems, IoT, and AI. I have also worked as a Udemy instructor. So if you want to reach out to me, you can check my Twitter and also check my GitHub.
Okay, so before we jump into a no-code AI-based containerization solution, let us spend some time understanding what is no-code and why are we talking about it. Now, the so-called no-code or low-code has gained a lot of popularity in the recent times. I was going through one of the survey report published by the Gartner, which states that by 2025, 70% of your new application developed by the enterprises will use a no-code or low-code technology. Now, I try to understand what's driving this significant growth. Now, to my surprise, I came to know that the surge in remote development during the COVID 19 pandemic is a major driver. Now, by looking at the fast growing landscape, one thing was sure like no code and low code are the future of software development. It is an approach to design and use an application that doesn't require any coding or knowledge of any programming languages, right? So, looking at the no code landscape, it's all about a family of tools that allows you or your developer team to build apps and systems without even having to program them in a convenient way. So if I really have to mention about the existing platform, few of them are highly popular. So just to name a few of them, like Airtables for databases, connecting your tools through Zapier, e-commerce via Shopify or Weebly, like these are quite popular, and especially not to miss out the Notion and Trello for the project management. Now these are the platforms which are like quite popular. Now, we talked about low code technology, we talked about no code technology in the landscape, but there is one technology or the subset of the technology which we want to talk about. It's basically a low code AI space, right? Now, low code helps you to maximize your 2x development speed with minimal coding. But if you're working on an AI space, then you might have come across another subsegment which is no code AI. And let us accept to the fact that it's always difficult for a non-technical person to go ahead and build custom AI solution and AI powered process automation, right? So no code AI is one such technology that allows your AI experts to build ML solution and faster with very few coding activities. And our talk is going to revolve a lot around the no code AI vision technology. Now, in this section, I'm going to talk about one of the low code platform that has gained a lot of popularity, I would say, and it has a huge community, and that is rightly called as a Node-RED. Now, if you have worked on IoT platform, definitely you might have heard about it. So I want to touch base on five important features you should be aware of when you are working with the Node-RED. The first one is Node-RED technology is basically a kind of a low-code programming language for event-driven application. Now, when I say event-driven application, it means that this piece of application is computer program that is written to respond to actions which are generated by the users of the system. Now, these events could be anything user-generated actions like mouse clicks or keystrokes, and system-generated events such as like the program loading. The second point is Node-RED is primarily a visual tool for building your workflow for IoT scenarios. So think of it as like if you really want to go ahead and wire or chain the IoT devices and services, the way how, okay, if this and then does most of the web application APIs and services. Third, Node-RED is built on very powerful Node.js, which is open source, cross-platform, backend Java platform, runtime environment that runs on Java engine, executes the Java code outside the web browser, right? So Node-RED's lightweight runtime is basically built on Node.js, and any developer can take a full advantage of Node's event-driven non-blocking model. The other point which we really need to capture about is, especially on the Node-RED, is it provides you with a browser-based flow editor. Now, to really understand the browser-based flow editor, in this editor we have a palette, and that palette contains all the nodes that are installed and available to use. And these are primarily organized into number of categories with both input, outputs, and the function at the top. So it is amazing to see that when you have such a robust web framework, so definitely you can go ahead and you can identify like how powerful the platform could be. And the other thing is, Node-RED flow works by sending the messages, by passing the messages between the nodes, and these messages are nothing but a simple JavaScript objects which can be also stored in the form of the JSON format. Now, when I started containerizing the Node-RED based application, one of the interesting stat I came across was Docker pools. It is amazing to see that users have downloaded Node-RED Docker image 100 million times from Docker Hub. And now you might think about, okay, what they are doing with this particular image and why it's driving this significant download rate, right? And there are few important reasons. I think any of the programming languages has been adopted by Docker, so there is an ever increasing demand for Docker containers to streamline your development workflow while giving the Node-RED developers the freedom to innovate with their choice of the project tailored tools, right? And one of the biggest reason why the Node-RED was adopted, has been adopted by a number of the developers, is basically it supports the multiple architecture like AMD 64, ARM, V6, V7, V8, and even S39X. So all of these platforms are readily supported for this. Now, in one of the report which I went through, it was published like around 1.5 years back, was around around 94% of the AI adopters, right? 94% of AI adopters, are planning to use containers within 1 year time. And the major reason being the faster time to deployment. Say 14.8% says like the faster point of deployment is the main reason. And then we have the other reason like the lowered cost, which is obvious. More efficient resource utilization. Docker has been there for a long time, and one of the basic reason why it is being used or replacing the virtual machine is the resource utilization, right? You don't really have to go ahead and spin up gigs of those instances over the cloud to basically run those containers. Today you can even run containers, or containers are powering those serverless platform which you can use, right? The other factors, which includes 10.4% of the adopters say like it's the increased portability as well as the easier management and orchestration. That is also one of the main reason. Now, considering you have a no-code technology, you have no-code AI vision, as well as the containers, what we try to do, I collaborated with one of the Seeds engineer, and we came up with a solution called as a retail store item detection system with no-code AI at the edge. And the Lakshantha would go next, explaining about how we integrated all this platform and try to build a robust solution which is based on the containers. So over to you, Lakshantha, so that you can go ahead and talk about this solution. Thank you.
So this will be the overall architecture of our solution. So RoboFlow will be used to annotate the dataset once you collect the dataset, and YOLO V5 will be used to train and object detection model. Also, the same YOLO v5 will be used for the inference on the device. Inference means detecting the objects. As for Node-RED, so Node-RED will be used mainly for this demo. So because this application will run on Node-RED with Docker as well. So Docker will, so we will have different Docker containers to containerize different parts of the demo, and we will talk later in this session how that is done. So there will be a camera module connected to the Recomputer Jetson device, and the camera module will pick up the video stream coming in, and then only this system will do all the detection on the received camera video stream. So for the setup, under hardware components, we will use the Sage Studio Recomputer J1010, which is built on top of Jetson Nano module. So you are not limited to use this particular device. You can use any Jetson powered device that is available. If you are interested to learn more about the Jetson products that Sage Studio offers, you can visit this URL and check this page where you can find a lot more Jetson powered kits and career boards. I also want to mention that Sage Studio is an official NVIDIA Jetson partner. So coming back to the hardware components, so after the Jetson device, we need a camera module for this demo. So you can either use a USB camera or an IP camera, which has the ability to send the video stream via the RTSP protocol. Next, we will need an internet connection for the Jetson device. So either you can use the Ethernet cable to connect to the internet, or use a USB Wi-Fi adapter. Finally, you will need a keyboard and a mouse to access this device. Or else, if you want to access remotely, you don't need the keyboard and a mouse. You can just simply SSH into the device. As for the software components, you will have to install NVIDIA Jetpack version 4.6.1 along with the SDK components. So Jetpack provides a Linux kernel, bootloader, an Ubuntu-based root file system, the drivers, and all the necessary firmware needed to use the Jetson device. So next, we need Node and NPM. So that will be installed later. I will show you later that they all will be installed. And also Docker and Docker Compose. So as for Docker, Docker is pre-installed with when you install Jetpack on this Jetson system. But Docker Compose is not pre-installed, so you have to install it separately, and we will do that later. So after making all the connections with the Jetson device, the webcam and the keyboard, mouse, or everything, so it will look like this. So this, for reference, this is the Sage Studio Recomputer J1010. Now it's time to dive straight into the demo. So this is what we are trying to build here. So this is the Node-RED flow editor, and we have added a couple of Node-RED nodes connected together. And we can see that there's a original video stream coming in from the retail store, and then under that video we can see that all the items are being detected by the system. So inside the flow editor, as we saw before, we have added a couple of nodes. So it's very interesting to see that each of these node corresponds to a Docker container. So this video input is one Docker, and the video weave is another Docker container, and the object detection is another Docker container. So when we build out the demo later, you will understand about this. And this is an overview of the Docker Compose file that we will use. So you can see that there are three containers here defined. So mainly this is the first Node-RED container, which is the Node-RED itself. And the next one is the data loader. So that is to obtain the video streams from the USB camera and the IP camera. And the third one is the detection Docker, that is to perform the object detection. So now I have SSH into the seed recomputer Jetson. So let's issue this command jetop, and we can see that the Jetpack 4.6.1 is already installed along with the SDK components. So moving on, I will show you this one at first. So this is the GitHub repo that I will show you as reference for this particular demo that we will use in this video. So you can see that this repo is a fork of the Seed Studio Node-RED contrib ML repo. So if you go to that repo, so this is the main repo of this development. And if you want to contribute to this Seed Studio repo, we have this program where if you submit PRs, we will gift you with store coupons and samples as well. So I will attach this URL at the end as a reference so that you can visit this and check more on that. What we will do is we will first clone this repo. So git clone this. So if we git clone this, so I have already git cloned this actually. So if we go to this repo, we can see that there are a couple of files inside. So I will explain one by one what these files are doing so that you can understand how this demo is built. So first of all, I will explain about this file, particularly the YOLO v5n.engine file, because that file is very important for our demo, because that is the YOLO v5 model file. So this file can be obtained after training an object detection system. So to obtain this file, so I have used this repo, the YOLO v5 repo by Ultralytics. So by using this, that's this command to do the training. So I have gathered a data set and trained using this command, and after training we get a file in .pt, that is in PyTorch format. So to run a PyTorch inference on the Jetson device, it will perform less. So to make the performance better, we have used an TensorRT implementation on the Jetson device. So TensorRT will help utilize the NVIDIA GPU on the Jetson Nano in a better way. So by using this repo, we have converted the PyTorch model into a TensorRT model. So we obtain this .engine file using this. So this is the engine file that is already there. So this is actually already trained with the retail systems items data set, so that it will be helpful for our demo to do the detection of the retail items later. And talking about this folder, so the Node-RED config folder. So if we go into this folder, we can see that there are a couple of files. So the README file I'm not going to explain, it's just a README, like a document. So at first is the package.json file. So this is kind of like a initialization file for Node-RED, for starting Node-RED. So it defines a couple of things like the version and the name and all the dependencies, because we will load this theme, the Node-RED theme, and then this dependency is the seed recomputer nodes. So we need to load those nodes. And for the settings.js, so that is also that also defines settings for the Node-RED interface. So these are some predefined settings that we have defined. Actually, this one is just the image. So just to it's just a logo, like a Seed Studio logo, which appears on the left corner of that Node-RED interface I just showed you. So that is just to replace the icon with this seed logo. If we go back again, the next file that is useful for us is the Docker compose file. So if we go into it, a couple of parameters are defined here. So we are using these 3 Docker containers, right? So this Node-RED is the main container that we will use. That is the main application. And the next will be the data loader. So this will be helpful to grab the USB camera or the IP camera video stream. So this will help with that. And the detection Docker container will be helpful to perform the object detection. Like it will contain the object detection algorithm to perform the detections. So that is the Docker compose file. And next, the final one will be the Docker ubuntu.sh. So this is a script, a helper script written so that we can easily plug everything together to make the demo work. So if I go through this script, so this is pretty basic. It starts with defining a few colors to appear on the script. So these colors are defined, and then here it checks whether we run the script as a sudo user. So it is very important to run this as sudo, because sometimes to perform some of the operations we need to have the right privileges. So by executing as a sudo user, we have the admin privileges. So then it checks whether the Jetson device has enough storage, because this demo will take up quite a lot of storage, around 3.8 GB as mentioned here. So because it will pull all the Docker containers from the Docker compose file that I just showed you. So what it will do is it will first check whether it has enough storage, and if it does not have enough storage, it will continue to delete some unnecessary packages. So here you see it's removing some unnecessary packages such as Thunderbird, LibreOffice, and also removing the GUI. So it's removing all the unnecessary stuff to make space for this demo, because normally when we use the NVIDIA Jetson device, like it comes with a eMMC storage of 16 GB. So out of the box, once you install all the Jetson OS and the SDK components and everything, you will not have enough space for this demo. So that's why this script is written, so that we can have the enough additional space to run this demo. And then it will install the necessary packages over here. It needs the curl, the Docker. Actually, this one, the Docker is already pre-installed on the Jetson device out of the box when we install Jetpack. But still, it will check for it, and if it's not there, it will install. And we need this NVIDIA Docker 2, and then the Docker compose, because we need this Docker compose file to execute that Docker compose file that I just explained before. And then it will copy the Node-RED settings file, the folder I just mentioned before, the Node-RED config folder. And next what it will do is it will perform this to bring up the Docker compose file. It will download all the containers and bring them all up. So here it will install the Node-RED theme package via npm because it is needed for our demo. Out of the box, just a simple theme is there. So this will make sure that the theme that we include in the Node-RED config file will be loaded. And then we restart the this container, this Node-RED container, for these theme changes to take into effect. So after this, this is also very important. So we need to copy the yolovfi.engine, the model file, into this container. So the detection container, inside this data build directory, we copy it into here, this engine file. So after we copy that, we need to define this also, the remove the label name. So for the detection that we use, it will contain a lot of labels because initially this the detection is done for the Coco data set with 80 classes, so it can detect 80 different images. This demo out of the box. So without this custom engine file. So when we load this engine file, and for this retail detection system, we don't need any labels to show, because the items will be shown very tightly. So it's better that we remove those remove the labels. So we just replace the first label in that file, the person label, with an empty label. So it will we will give an empty label to it. So after doing all this, we will simply restart this detection docker. So once we restart this detection docker, everything will come up. So actually in this Jetson system, I have already run the Ubuntu Docker this script. So this docker ubuntu.sh is already, I have already executed that, because if I do that in this video, it will take some time to process. So it's already done. So if we go to docker ps, so that's to check all the running docker containers. So we can see that the 3 docker containers are already up and running. And if we open this web browser and check this IP address 1.195.195 and go to port 1880, it will load the Node-RED flow editor. So this is the Node-RED flow editor. So this is what I just mentioned before. So this is the seed logo that we replaced from that file, and then it's pretty simple now. So as a no code implementation of this demo, so you just need to drag this video input block and the video view block, just connect these 2 blocks together, and then if we go into the video input block, we can see that you can define whether you want to get this, obtain the stream from the USB camera or the RTSP IP camera. So in this case, we will use the local camera, that is the connected USB camera. And for the video weave, we don't need to do anything. So next, we will just take this block, so object detection block. So that is where the detection of the objects is being performed. So we will just connect these 2 blocks together and add another video view block. So this will be the raw video output from this video view block, and then from this video view block we can see the detection with bounding boxes on this video stream. So what we will do now is we will upload this to the Node-RED system. So click this upload button, and now we can see all the items in the retail store being detected by the system.
Okay, cool. So we are towards the end of the session, and this is one last slide which I have included. These are full of the references which you can go through it. I have tried to include all the blogs as well as the wiki pages which you can go through. I've also tried to put all the links to the Node-RED. Maybe after the session you get access to the slides so that you can always go back and try to see what we have tried to build out of it. With this, I would like to thank each one of you for your time in watching us, and yeah, have a great rest of the day. Thank you.